Hello, Year 10. Welcome to the motion booklet. This is all about speed and distance and time and stuff like that. And a very important part of lots of engineering applications. So we're going to start with some relatively straightforward stuff all about speed. So in this lesson, we're going to have a quick look at the speed equation, which is in front of you in your workbooks. And then we're going to get on with a little experiment to do with little cars and tracks and stuff like that. And maybe in your class you'll find out the fastest car. So first off, when we look at speed measurements, there's two things we need to know. We need to know the distance the object has travelled through. And we need to know the time it took to do that. And from that, we'll create this equation where speed is distance over time, which I think you're probably familiar with. You may not be familiar with the rearrangements, so we can rearrange it to make what we call distance the subject or time the subject. If distance is the subject, then speed times the time. If we think about this, the speed is the distance per unit time. Usually in class it's meters per second. So how many meters does it go each second? And therefore, if you multiply that by the number of seconds it's travelled for, you get the total distance travelled. So imagine something travelling at 5 meters per second times 10 seconds. That would then equal 5 plus 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 5, 10 times, obviously. And that gives you 50 meters. When we look at the time version, we go, okay, so what was the distance that it travelled over? And what was the speed it was doing? So now we've got a similar kind of idea, but in this case, we're going, okay, so let's imagine our distance was 75 meters. Okay. And we are travelling at the same speed of 5 meters per second. So every 5 meters takes 1 second of time. Therefore, how long is it going to take to cover 75 meters? Well, in that case, you want to know how many times does 5 go into 75? And that will tell you that this journey would have taken 15 seconds. So that's those other two equations here. And the first equation is the original equation, which simply tells you the ratio between how far you go in the unit time. The unit time in labs, in science labs, is usually a second. In real life, it's more likely to be an hour, kilometers per hour, miles per hour, etc. Okay, the formula triangle to the left here, what we do is we cover up one of the unknowns, in this case S for speed, and that leaves us with this relationship d over t, distance divided by the time taken. If we move our dot to d, we then see that it is the distance, which is covered, would be the speed multiplied by the time taken. And finally, if we move our dot to t, we can see that our time, which is the covered one, would be the distance divided by the speed that it was travelling at. So if we now jump to the back of the book, you'll find these speed calculations. This is just a little chance to do a little bit of practice, and then you will finish this for homework. So let's look at the first ones. It says, first of all, let's remember 1 hour, 60 minutes. Here we go, 1 minute is 60 seconds, and X minutes divided by 60 gives you the hours as a decimal. So just a basic maths of time. So if you're in a car on the M1 doing a steady 70 miles per hour, then you will travel 70 kilometers every hour. So in 2 hours, you would travel 140 kilometers. Simply 2 times 70 equals 140. So our equation that we're using here is our distance equals our speed times our time. Like that. And I would always suggest you write your equation at the beginning of each calculation or at the beginning of a set of calculations that are all effectively the same. So in this case, D would equal 3 multiplied by 70, which equals 210 kilometers. In this case, D would equal 1.5 times 70, which equals 70. Half of 70 is 35. 70 plus 35 is 105 kilometers. Okay, and finally, D would equal half an hour times 70, which is going to equal 35 kilometers. You should now try these ones yourself and check your answers in the WHS campus teacher copy. Okay, so you're now traveling at 40 kilometers per hour. Okay, so question 2 is about calculating speed. So speed equals distance over the time. A little equation. So we'll now apply it to these questions. Okay, so 40 kilometers in 2 hours. So our speed will equal our 40 divided by 2. So 20 kilometers per hour. 30 kilometers in half an hour. So these can confuse people a little bit when they're decimals. Our speed will equal 30 divided by 0.5, which equals 60 kilometers per hour. Don't be tempted to write 15. Okay, it's 30 divided by a half, which is double 30. So if you think about it, if you do 30 kilometers in half an hour, you're going to cover 60 in the whole hour. So your answer should be bigger. Okay, not smaller. Part C. So speed will equal 75. Now, this 45 minutes we can't use. We have to turn this into hours. So how much of a fraction or a decimal of an hour is 45 minutes? Well, it's 45 over 60, which is 3/4, which is 0.75. So now I can see that if I do 75 kilometers in 45 minutes or 75 kilometers in 0.75 of an hour, I'm going to get 100 kilometers covered in the whole hour. Okay, and finally is 210 divided by 2 point. Now we can't put 2.20 because 2.2 is not the correct decimal representing 2 hours 20 minutes. How much of a fraction of an hour is 20 minutes? Well, 20 minutes is 1/3 of an hour. Okay, so our decimal becomes 2.33. Okay, and that gives us an answer of 90.1 kilometers per hour. Right, so now try these ones about a frog. Now the key thing about this is we're talking about centimeters per second. Okay, so that's fine, just leave them as centimeters or possibly in these cases meters. Okay, so I would just keep the seconds are fine. Okay, but you might want to change the centimeters to meters and get everything in meters per second, or you might want to change the meters into centimeters and get everything in centimeters per second. So try those now. Finally, question 3 here is about finding the time. So we have to remember that our time taken would equal our distance divided by our speed. Like that. So in this particular case, we've got kilometers and a speed in kilometers per hour, kilometers, speed in kilometers per hour. So these should all come out in answers of hours. This here will tell you what the time unit is of your answer. So if we try the first few, we have, in this case, our time will equal our 500 divided by our 100. Okay, so our answer will be 5 hours. Next one, time will equal 320 kilometers divided by 80. So that would equal 4 hours. Next one, time will equal 180 divided by 120, which would equal 1.5 hours. And finally, part D, our time would equal 234 divided by 93. And that equals about 2.52, which is equivalent to 2 hours. And you need to take the 0.52 and you multiply that by 60, and that will tell you the exact minutes. In this case, about 31 minutes. Okay, so now the best thing to do, you try the rest of these yourself.